Hi, welcome back to Moose in Chemistry. This is VSEPR Models lesson number 3. We're going to try the compound nitrogen triiodide. So that's going to look like this, Ni3. Okay, so nitrogen is in group 15. Get rid of the 1, and we will have our 5 valence electrons. Iodine, of course, is in group 17. So we'll get rid of our 1. We're going to have 7 valence electrons. So when you look at that, the one that has the most opening docking ports, of course, is nitrogen. All right, so we're going to go ahead and we're going to do the math. So nitrogen has 1 times 5 electrons. Iodine has 3 times 7 electrons. This is going to give me 21 electrons and 5 electrons. So this structure is going to have a total of 26 electrons. Okay, great. So now what we're going to do is we're going to go ahead and draw our structure. And we put the N in the core. Here are our lone pair, unshared pair. We're going to put, of course, our 3 dots there. Then we're going to hook in our I's. So we've got an I here. We have an I there. And of course, we'll have an I there. All right, and then we do the little wraparound dots here to give each of the I's their octet. Well, 3 I's times 8 electrons is 24 electrons, plus this unshared pair right here gives me a total of 26 electrons. So now this is the best possible structure. Let's look at the formal charge. Formal charge is valence electrons minus bonding electrons minus non-bonding electrons. I've also seen it written as formal charge as valence electrons minus non-bonding electrons minus bonding electrons. It doesn't really matter, it's going to work out. So the formal charge for nitrogen will be nitrogen comes in with 5 valence electrons. 3 of them are bonded. You can see these little bonds right here to the I's. Okay, so you have 3 there. And you have your unshared pair, of course, minus 2. That will give me 0. That's a good start. The formal charge for iodine. Iodine comes in with 7 valence electrons minus 1 bonding pair of electrons minus 6 non-bonding electrons. So that also gives me 0. So I don't need to do the other I's because they're all the same. Well, let's look at the structure. We have A for nitrogen, X, 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 and we have at least 1 unshared pair. This would make this A, X, 3, E. So if you look at our chart up here, AX3E is a trigonal pyramid structure. Okay, well that's it for this lesson in Moose in Chemistry. You guys be snarly, and we'll see you back here at Moose in Chemistry.